When we read this problem, we see that we're mixing solutions together, and we want to know which, if any, compounds precipitates. This is going to be a type of beaker problem. So the first thing is to determine the ions in solution, and then we test all possible cation to anion combinations, and if there is an insoluble combination, then that's going to be our precipitate. And we remind ourselves there could be more than one precipitate. Here's our physical interpretation. These are all soluble ionic compounds. Soluble ionic compounds, when they're dissolved in water, dissociate into ions. So we recognize each ion that's going to be present in solution. So when we mix all these three solutions together, these are all the ions that are present in solution. We're making our life easier by keeping the cations on the left-hand side and the anions on the right-hand side. That reminds us that when we write the formula of the ionic compound, the cation is written first. These are all the possible combinations of the potassium ion with the different anions. When we consider our solubility rules, we know that all of these are soluble. They will not precipitate. All potassium compounds are going to be soluble. These are all the possible combinations with the aluminum ion: aluminum carbonate, aluminum sulfate, aluminum nitrate. We consider the solubilities of each of these. Aluminum nitrate is going to be soluble because all nitrate compounds are soluble. Most sulfate compounds are soluble. Aluminum sulfate isn't one of the few exceptions, so we know that this is also soluble. When we are applying the solubility rules, we want to consider the cation and anion as a pair. First, we identify what the general solubility rule is and see if there's an exception. In the case of aluminum carbonate, we see most carbonates are insoluble. Aluminum carbonate is not one of the exceptions. Therefore, aluminum carbonate is an insoluble compound. I want to take a moment to remind you to use care to write the correct formulas, i.e. so that you have the right combination of ions. Lead's 2+, carbonate's 2-. So this is the appropriate formula for lead carbonate because the number of positives equal the number of negatives. Solubility. Lead carbonate is insoluble. Most carbonates are insoluble. Lead's not any exception. Most sulfates are soluble. However, lead sulfate is insoluble. It's one of the exceptions. All nitrates are soluble. There are no exceptions. Now, to answer the question, the insoluble combinations are going to be our precipitates. In this case, there are three: aluminum carbonate, lead carbonate, and lead sulfate.